Okay, this is 5.2 perpendicular angle bisector notes, day 1. Perpendicular bisector is a segment drawn through a triangle that intersects one side at a right angle at its midpoint. So that tells us that it's a right angle, and each segment on that is congruent. So what we know about this, it creates a 90-degree angle and bisects a segment. It may or may not bisect an angle. Okay, we can't guarantee that. But an angle bisector is a segment drawn through a triangle that divides an angle into two congruent angles. So these two angles would be congruent. And what we know there, it creates two congruent angles, and it may or may not bisect a side. Okay, now let's look at the theorems. Perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. So this is saying if AB is perpendicular to XY and AY is equal to YB, then AX is equal to XB. Okay? AX is equal to XB. Now, the converse of the perpendicular bisector theorem is if a point is equidistant from the endpoints of a segment, then it is a perpendicular bisector of the segment. So, if AX equals XB, and remember this here is an isosceles triangle. So if AX equals XB, then XY is perpendicular to AB, and AY is equal to YB. Excuse me. Okay, now let's look at the angle bisector theorem. If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So, what this is saying is if NQ, so basically we're going to be given this and we're proving this, okay? So if NQ bisects MNP, and NM is perpendicular to NQ. Now we know it bisects because of the angles are congruent here. We know that it's perpendicular because of the square. And then NP is perpendicular to PQ. Then we know that MQ has to equal QP. So this is just saying this is the angle bisector theorem. Now, if we look at the converse of the angle bisector theorem, if the point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. So what this is saying is if we're given that NM is perpendicular to MQ, that's a horrible MQ, and NP is perpendicular to PQ, and MQ equals QP, then NQ bisects MNP. All right, so let's apply it. So we're going to be using the angle bisector theorem. So first off, just by looking at this, I want you to see what the theorem is saying about this. So what I am seeing here is that we have an angle bisector, we have a perpendicular. So here we go. It would be saying that if QS bisects angle RQT, QR is perpendicular to RS, and QT is perpendicular to ST, then we would know that RS equals ST. And that's what it's showing us. This is our bisectors are congruent angles, and then this here is perpendicular. So now we're just setting, by that we know that these are equal to each other. So now we're going to set that up to make them equal to each other and solve for x. So 5x minus 30 equals x plus 14. Subtract x, add 30. So 4x equals 44, divide by 4, x equals 11. It's asking what RS is, so I have to plug it in. So 5 times 11 minus 30. 55 minus 30 equals 25. So RS equals 25. I would pause the video and do this one. Okay. Okay, so I wrote down what the theorem would be. But what you need to do for solving this is you are just setting them equal to each other and solving for x to start with. So 13x minus 60 equals 5x minus 4. Add 60 and subtract 5x. 8x equals 56. Divide by 8. X equals 7. So I plug that back in to our xy. So 13 times 7 minus 60. So I have 91 minus 60. So my answer is 31. So xy equals 31. All right, so let's do example 1. JP is the perpendicular bisector of MK. So we know that JP is the perpendicular bisector of MK. So we know this and this are equal, and we know these two things are equal based on the perpendicular bisector theorem. We can also know that it tells us that these two sides are equal, because really this line is going through all the way. So first off, MK. Well, if MK is 35, I'm just going to take 35 times 2 to get 70. Because NK is 35, so MN is 35. So MK is 35 plus 35. Find JK. Well, first I need to find what Y is. I know that these are equal to each other based on the theorem. And then that tells me that 7y minus 6 equals 5y plus 8. I add 6, subtract 5y. 2y equals 2. Oh, nope. 2y equals 14. So y is going to equal 7. So then I need to plug that back in for y. So I have 5 times 7 plus 8, 35 plus 8. JK is going to equal 43. Find ML. So you're going to do the exact same thing. You're going to put 9y minus 13 equals 7y plus 1. Subtract 7y, add 13. 2y equals 14. So again, y equals 7. So I'm going to plug that in. 9 times 7 minus 13. 63 minus 13 equals 50. By the way, the question that you need to answer, my favorite holiday candy is peanut brittle. All right, 2 more examples. I would, again, pause the video, do the examples, and then, or do the problems, and then solve, or then check them, rather. All right, find the measure of angle CBE. So CBE is right here. All right, so this is actually, let's look at it. We're going to break it down. This is saying if BD is perpendicular to DE, BC is perpendicular to CE, and DE equals EC, then that means that DE is bisects angle DBC, which tells us that these angles are congruent, so angle CBE equals 31 degrees. Well, let's look at this one, find x. So it's an angle bisector again. So we're just going to solve, because again, we know that these are perpendicular, these are equal, so then this tells me that these are equal. So I have 3x minus 5 equals 2x plus 5, x equals 10, and there's your answer. Let me know if you have any questions.